Good morning, everyone. I know Google Next party was last night. We appreciate you being here with us, with your caffeine and being with the database team. We'll surely make it your worthwhile. Today, we're going to talk about agentic data cloud platform that's going to help you optimize your data cloud fleet. We are moving away from human scale manual operations buried in reactive firefighting to actually agent scale operation to deliver an intelligent data cloud management system, a true system in action. Before we dive in, I want to take a moment to introduce a team that's going to walk you through this journey. I am Nitya Ramani. I'm the Senior Director of Engineering at Google Cloud. Joining me would be Niranjan Shivprasad. He's our Group Product Manager for databases. And we are thrilled to have Govindaraj Palanisamy, a Principal Enterprise Architect at Global Payments. Govind will bring the most important perspective for you all, which is taking all the innovations that we've done and how they're going to be using it in their complex data environment. Thanks, Govind, for being with us today. This is the agenda we're going to be talking today. First, we'll introduce our new agentic solutions through database observability agent. We will then talk about how we are enabling your developers and empowering them to use our agentic platform. Then we will zoom out and talk to you a little bit more about our data cloud fleet management solutions. And then to bring it all home, Govind is going to help us talk about how Global Payments is planning to use our solution. What are the challenges that we are facing today with our data fleet? The modern day database management has become very complex and extremely diverse. And we are too reliant on a handful of experts to solve all the problems. And this is leading to bottlenecks and high mean time to resolution. So the goal that we are choosing to solve is we're going to flip the script by leveraging AI. We want to democratize the specialized knowledge and open it up for your developers to solve their own problems, to improve the MTTR. And mostly with that, we're going to enable your experts to have more time to do more strategic work. As you have been hearing last few days, the next wave of data and analytics is agentic. Modern day data foundations has unified the data to bring it all together in one place. The next phase of evolution is going to be data and AI are going to fuel and enable agents to automate tasks as well as deliver insights at scale. Last 2 days, we had announced many things. Amongst them, one of the biggest announcements was world's first agentic data cloud. We unified architecture that integrates AI models, analytics, and operational databases all into a single AI-native solution, a true system of action. What does that action actually look like in practice? So today, we are trying to show you how we can move from tedious, complex tasks in database management from human scale to agent scale. We are introducing Database Observability Agent, an AI-powered observability agent, which can correlate hundreds of metrics in real time to troubleshoot and optimize your operational databases. It not only can diagnose the issues, we also provide recommendations so that you can solve the issues right there. This is how we plan to transform your operations and allow your team to build more strategic solutions rather than firefighting. And what does an agentic cloud look like? And how can we make it usable for your teams? So the first thing we are doing is we're taking the database observability agent and providing it with high-fidelity telemetry so that it can transform and translate and provide you with precise insights as well as actionable recommendations. We're also deeply integrating it with Google Cloud Assist so that you can interact with this database agent from Google Cloud Console, from your favorite IDEs, or any third-party tools, as well as chat. We're also expanding the support, and we are enabling AlloyDB, Cloud SQL, Bigtable, and Spanner, all in private preview mode for you to leverage the power of agentic platform. As you can see, it is a pervasive, intelligent layer and turns every interface into a system of action. My colleague Niranjan will walk you through the details and show you some exciting demos to help you understand how this all works. Thanks, Niranjan.
Good morning, everyone. Thanks for being here. So my job is to take you through a whirlwind tour of the agent's capabilities across the many surfaces it powers, the many journeys it enables, and the many complex tasks that it solves. I'm going to start with the first one, which is how it enables database intelligence at your fingertips in wherever you are. Now, the first area where the agent really redefines access to database intelligence is chat. Now, a lot of you may have already used Google Cloud Chat in some form or the other, but what we've now done is redefine chat to be fully agentic. What that means is twofold. One, chat has now access to the broadest possible sources of database knowledge that you can have. Everything from query insights to system insights to fleet inventory to issues and recommendations and logs and traces and everything else that matters for all of your managed databases. But not just that, we've added a layer of intelligence on top of that telemetry where thousands of metrics are now well understood by the agent so that it can answer complex questions for you. Agent now understands resource hierarchies for different database engines, understands what a tuple means, what fatal errors mean, what query latency means, and presents them in an actionable format for you. Let's see the system in action. So let me walk you through a demo that kind of simplifies and demonstrates how you could execute a workflow like this with just a few simple clicks. Now, I am on Database Center, which is our database management fleet solution that's just pre-built into the console and lets you monitor the health of all of your databases from a single pane of glass. What I'm going to do is just ask it an open-ended question on what are the CPU utilization trends for all of my Cloud SQL instances, right? So what the agent will now then do is go through all of the telemetry in the backend and come back with a trend line that not just shows you the trends of your worst performing Cloud SQL instances, but also your best performing instances. And the agent will also identify a couple of instances that may be really hitting the limit of CPU utilization in this case, right? And now what I'll do is also ask it, are there any inefficient queries in this high CPU instances that particularly need my attention? And there you can see again in chat that the trend line for the inefficient queries is charted. And also, agent gives you a brief summary of what's happening to those queries, right? So they've experienced extremely high latency, and the average execution time of these queries has been increasing over a period of time. It also offers you to help you find root causes and remediations that you can utilize to improve the query performance here. But before that, I want to know the specific queries that are running slow in these instances, right? So I can simply ask that question. It will list all of those queries. It will rank them by execution time, and also tell me what else I could do to go ahead and probably start a deeper investigation to get to the actual root cause of why a specific query is running slow or a CPU utilization is really, really high. Now, what I did here was start from an open-ended question of what's my CPU trend line for all of my Cloud SQL instances, and then dig down into a specific query and the query's execution time. I will, at a later point in the presentation, also talk about how we can take multiple steps forward from that point onwards to actually investigate the root cause of the query performance and go fix it. But before that, what else can chat do for you? So now that was an example of very common metrics that you typically deal with, which is CPU utilization and query latencies and execution times. What if you want to ask an even more complex question, which is even more open-ended? Now, obviously, one of the common questions that you would get from your application teams is, have there been any repetitive fatals or errors in any of my databases that have impacted my application over the last week or a few days, right? Now, a very difficult question to answer, because what if I have 300 plus or 1,000 plus database instances? I'll then have to go look at the logs of each one of them, find fatals, find errors, try to correlate the root cause for each one of them, and try to see if there's a common theme that can be applied to solve these issues. But there's a simpler way to do that, right? So you could just ask the Gemini Cloud Assist chat, which is database chat in this case, and say, for my Postgres databases, can you list all the fatals and errors that have occurred in the last week, and also give me remediation input. Tell me what I could do to go fix it. And what it'll do is actually go through all of your logs and traces, all of your database metrics for your entire fleet, and come back and list your most common fatals and errors. So the first one in this case you can see is that there seems to be a bunch of connection issues, right? The connection to client lost fatal errors that have reoccurred in a specific instance, which is Office Supplies. I didn't ask it or provide the instance name here. It's something that it came up with on its own by looking through logs and metrics, right? And it's not just telling me that, it's also telling me what I could do to potentially remediate it. I could check my application timeouts. Maybe they're too aggressive. I can check my network stability. Maybe there's a problem there. Or I've not implemented connection pooling for my Postgres Cloud SQL instances, which could have remediated this issue and given a long-term fix for it. So it gives you multiple options after discovering a correlated set of issues for your entire database fleet. The second one it seems to have found is that there is a lot of auto vacuum task cancellations. Now, again, it lists the instances that are impacted by this. It will also tell you what you could do to remediate it. Maybe your auto vacuum configuration is too aggressive. Maybe you need to increase the limit for it so that it can actually complete in time without getting interrupted by DDL updates or user queries. So all of that in just a few simple natural language prompts that happen to be available in your console so that you don't have to go traverse through thousands of logs and spend manual hours to find the same information and find the potential remediation steps for you. Now, these were what we call as reactive intelligence, right? So you essentially knew you had a problem. You knew that there could be some impact to your application teams, some impact to your end user teams, and you started from a position of, I know there's a problem in my database fleet. I'm trying to discover those problems. I'm trying to find what could be a potential solution for them. But with AI, you want to move one step forward, right? You want to actually have proactive insights generated by the AI agent before you actually find out that there's a problem from your consumer teams. And that's what we are moving towards with Database Observability Agent. What the agent enables is a intelligent set of proactive performance and inventory and health insights across your database fleet that are available in Database Center anytime you go in there, that finds issues that matter across the fleet by correlating them with other events that may have occurred. Maybe you went through a maintenance update and that led to certain consequences for your performance, for instance. Maybe somebody changed a bunch of database flags and that led to slowness in performance for a certain other set of instances. So it goes and finds all of those potential issues and presents to them in a single pane of glass for you to take action on. But it doesn't just stop there. That's issue discovery. So you found out in your fleet of hundreds of thousands of databases what needs your attention, what needs to be fixed. But where the agent really helps you is take you that next set of steps with the assistance of AI. What it will do is enable you to investigate, which is essentially a term that we're using across GCP for deep root causing and deep troubleshooting. So it lets you investigate the issue, finds evidences for a bunch of root causes that it can then present back to you as the potential causes for why the issue occurred, and also lets you remediate them in context. It will give you a bunch of steps that you can execute in context to get rid of the issue and verify that the solution's been effective and the issue no longer applies. So let me take you through one specific example of how you could do that for Cloud SQL. Right, so this is, again, I'm going to start with Database Center. You could start this journey from chat, from Database Center, from application pages in Google Cloud, etc. But I go to the performance page in Database Center, and what you will see is these performance insights that were dynamically generated by the agent that finds multiple issues across your hundreds of thousands of database instances, whether they're Cloud SQL or Alloy or any other engine. I see one that says, my production instances of Cloud SQL seem to have connection issues. And I click on them, it'll give me a summary of the critical findings, why it thinks they are having issues, and also lets me investigate that performance against each one of those instances in context. So I just click on investigate the performance for one of those, the simple app in this case, and it will open up on your console a deep investigation module, which will go through thousands of metrics in the background for that instance, look through logs, looks through metrics. We have a layer of reasoning that's built on top to really find the highest priority root cause for you and not give you generic recommendations. And what you can see here is it's actually come up with 3 separate hypotheses of what could be possibly causing that high CPU and connection pressure for your application and for your database. One obviously is the connection limits. It also seems to think that your database is under provisioned a little bit, and it's also found that you seem to be facing a malicious brute force attack from one single IP. Now let's go and look at one of these hypotheses. In this case, let's go look at the connection limit. That seems to be a problem here. So again, what it will do when you click into the hypothesis, it will give you detailed analysis of why it thinks that's a problem, what is the evidence backing its analysis, and what has changed in the last day or 7 days for it to think that there is the connection limit is a problem. It will also give you detailed remediation steps. In this case, it's telling you what you can do for immediate mitigation, what you can do to eradicate this problem altogether. Seems to be that a lot of the connection attempts are coming from one single IP and one single user, so maybe that's an IP that you want to block. What you can do to verify after the fix has been applied, what you can do to verify if that's been effective, and also what's a long-term solution for this if this issue keeps reoccurring, right? So maybe the long-term solution is indeed to increase your CPU. Maybe you are indeed CPU constrained, but what the investigation is trying to do is eliminate all other possible root causes of this issue, and then only maybe look at increasing your CPU size so that you don't rerun into this issue. Now, within the context of that window, I can click on generate a plan, which means I want to remediate it now. I trust the remediation and the evidence is there. And it will immediately generate a plan for me and say, give me the run command that I can copy and go to my AI Studio and apply it, or go to my Terraform script and apply it. Or if you choose to, you can just run it in context, and the agent will apply the change on the database on your behalf. It is, of course, taking care of all of your IAM requirements only if you, as the user who's doing the investigation, has the permission to make this change on the database, will it apply the change? Otherwise, it will not. So from a security perspective, it takes care of that. And as you can see, it's applied the increase to the max connections limit. It's also cleared all the authorized networks, and it's also telling you what you can do as potential next steps. So you can go ahead and verify it, make sure your application timeouts are no longer occurring, and also if you continue to see repeated connection pressures on this particular database instance, you should probably go ahead and increase the CPU for it. So all of this in just a few minutes, from actually discovering the issue through a proactive insight on Database Center that this specific set of Cloud SQL instances had connection pressure, to fixing it is probably a 5-minute journey, which would manually probably have taken me a few hours as a DBA or a platform engineer earlier. So that's the simplicity with which the database observability agent really empowers you with, so that you can focus less on tactical tasks, focus less on solving reactive pressures, and more on whatever your strategic objectives are, and really think about who you can enable this kind of capabilities with, right? So it doesn't necessarily have to be your DBA or platform team. You can even enable this functionality to your application teams and developer teams, so that they can then do the first level of triaging and first level of troubleshooting on their own. And when they actually raise a ticket on you as the platform team or the DevOps team or the DBA team, you already have a concise set of information on what was available, what was triaged, and what's possible. Now, what I showed you is a specific example for Cloud SQL. We are happy to announce support for this functionality for multiple managed databases. Let's dive a little bit deeper into each one of them. For Cloud SQL, we're happy to announce support for both Enterprise and Enterprise Plus editions for solving a very broad set of database issues. from query performance, resource exhaustion, connectivity issues, replica lags, and everything else possible. So we run a very exhaustive eval suite on the agent to continuously find new issue types and troubleshoot them and make sure their accuracy and precision is up to the mark. So that's available for Cloud SQL in private preview today. Similarly, for AlloyDB, we are announcing support for query optimization, resource optimization, and replica lag optimization. Again, all of these engines are currently in private preview, so you'd have to sign up for them, but they will go into public preview in a short while so that there's broad access to it. We're also excited to announce support for this for Spanner and Bigtable, couple of our native Google Cloud databases for troubleshooting the most common type of database performance issues that the users of Spanner and Bigtable typically run into. This includes everything from high latency read and write latency optimization, query optimization, as well as troubleshooting things like hotspots, right? So these are cloud-first global scale databases that are very, very powerful to run global scale applications, but typically needed a lot of expertise to troubleshoot, and we can really, really simplify them with the capabilities of this agent. Let me take an example for Spanner specifically. Let's say I'm trying to run a load test of on one of my Spanner instances, which is backing, let's say, a payment app for my retail organization. Typically, when the load test runs, Spanner has hundreds of different types of metrics, from transaction insights to lock insights to query insights to system insights and more. And you would really need to know what to look for and where to look for to see if everything is going as expected. But let's say you're running a load test, you see slowness on your application, you see CPU spikes and latencies intermittently spiking as well. How could we go troubleshoot that? Right, so we do have all of the telemetry available in each of these Spanner pages. So there's a lot of insights that you can see in these pages where there is multiple organizations of insights and metrics. But what we have now enabled is this new functionality called Explore Investigations, where instead of going manually through the metrics, you can simply choose to investigate a particular issue. So in this case, I'm going to investigate the CPU utilization, which is spiky, and let's say the application team has already told me that the latency is uneven. You can see that it's gone through a lot of different observations and come up with a specific hypothesis. It seems to think that there is localized hotspotting in the Singers table, right? And I can click on the hypothesis to find more information about why it thinks that's the right hypothesis and what is the evidence backing it. You can see that it's looking at the different log stats that we have, the split stats that we have, the transaction stats that we have, and come up with a deep root cause of the way the Singer tables is set up, with the primary key being sequentially increasing in 64 key, is causing a localized hotspot, which means that even though your overall CPU utilization is pretty good, you have a localized hotspot on a specific node, and all of your new scaling up writes are hitting that specific node, and therefore you have a latency issue. So this is a very common problem that we run into with Spanner use cases, where customers think that the CPU overall looks great, the memory utilization looks great, but my latency is slow. So what could be potentially causing that, right? So as you can see here, it's actually found the root cause to be just the way the primary key has been set up, which causes the hotspotting to be localized to one specific node. It tells you what's the remediation that you can apply, right? So you can change your primary key to a non-sequential UUID key that will distribute the writes to all of the nodes and not localize it. It will tell you how to do that, right? So it's also giving you the specific command for it that you can then choose to, again, apply in context on the console, or you can copy paste it and go apply it to in your DevOps workflow. So that would immediately fix it. It'll also tell you how to verify it, right? So how do you verify that the change that you've done to the primary key is effective, and now your writes are getting distributed across all of the nodes. Therefore, you have better latency and better application scaling. So all of that, again, is we've spoken to Spanner customers, for example, who said this is the most common type of performance issue they run into. Typically takes them a few hours to troubleshoot, find the specific transaction fingerprints and the transaction IDs that got impacted by this, and then go resolve it. All of that in just a few simple clicks with the power of the agent and what it's capable of. So that's an overview of how you can do a lot of these journeys within the Google Cloud Console. But one of the common themes that we hear from our customers is you want to shift left and empower your developer teams and your application teams in the surfaces that they are using to leverage these kind of capabilities so that they can do self-service troubleshooting, at least for the initial layer of troubleshooting on their own, and only come to the central platform teams and central DBA teams when the issue is not resolvable on their end, or they have a solution but they do not have the permissions to apply the change on their end, right? So, but there are typically two challenges when trying to do that. One is a lot of the observability and troubleshooting tools are generally product and service specific and do not cover the entire application stack end to end, right? That's a very common problem that I think most of you would have encountered at some point. The second challenge that you typically see is that these observability tools are not democratized and made available to your application teams because you generally need a level of expertise to even use the observability tools or use the troubleshooting tools, and you cannot train everybody to be an expert in understanding how those tools works, what metrics to look at, how to correlate them, how to troubleshoot with them. Those are the two key challenges that we are trying to address and solve for with the observability agent in two ways. One, Nitya did refer to this earlier, where everything that the observability agent is capable of, we are plugging that natively into the Google Cloud Assist GCP-wide Uber agents, whether you're trying to deploy a new application, deploy a new set of databases, optimize it, monitor it, troubleshoot it, you can now leverage the capabilities of the observability agent in your application layers, which means you can troubleshoot an application end to end by selecting all of the associated resources for the application and running this deep investigation across them. So you don't get a root cause for a specific database only, you get the root cause for the entire related application resources, from everything from, say, your GKE to your Cloud Run to your network to your database and GCS and so forth, so on and so forth. So at the Cloud Assist layer, you get a summarized root cause across all of them, and you could then go double click on it to find which one's actionable for you and which one you want to remediate. The second thing that we are doing is enabling all of this intelligence via MCP tools. And today I'm super excited to announce general availability of two key database observability MCP tools, our Database Center MCP tool and our Database Insights MCP tool. Both of them are generally available and they're available in the Google Cloud-managed remote MCP server. So it's very low lift to go access them and plug them into any IDE of your choice. Any Gemini CLI or third-party IDE of your choice, so that your developers have access to all of this information, all of this database intelligence in their workspace, right, in wherever they generally code and develop their applications. And let me give you an example of this with a demo that's run on Claude, for example. So what I'm doing here is asking, I've basically plugged in these MCP tools into my Claude surface. I'm asking them which MCP tools are and servers are configured. It tells me that it's configured with Database Insights and Database Center. And then I'll ask a very broad question. How is the performance for my project doing today? Right? So I have a simple retail project, and I want to know what the performance is. Maybe a little bit small on the font, so bear with me on that. But what it essentially did there is actually give me a full inventory of all of the many different database instances that are running in this project. So I have 407 database instances that are running in the project. Unfortunately, 396 of them seem to have some issue or the other, and 40 of them have really critical issues. So they're really at like very high CPU utilization, right? So a common trend that you see. So, but what it does is it's listing all of the different database instances by different issue types, from high CPU to some instances don't seem to have backup taken in a long while. Some instances seem to have security issues, and so on and so forth. But it'll also summarize for you what maybe needs your immediate attention by classifying these issues by severity. What is critical, what is high, what is maybe something that you can look at later in the day. And there seems to be, in this case, for example, 40 critical issues, 40 critical database instances that are impacted by performance issues. Now you can also see the breakdown of the different database engines in my inventory, and looks like, you know, the biggest one that I have is Cloud SQL. So I'm going to ask, how is my Cloud SQL fleet doing from a performance perspective, and let me see if there are any Cloud SQL specific instances that have a performance issue. So again, within my IDE, I'm just going to ask that open-ended question. What it'll do again is go look at all of the many hundred Cloud SQL instances I had and fetch all of the data and give me a prioritized list by CPU utilization, by connections, by disk reads and disk writes. Obviously, again, my prompt was open-ended. You could go specifically look for a metric and order it by that specific metric. And I seem to have one instance called diagnostic server, which is at 100% CPU. So what I'll do is I'll try to find, what are the queries on this instance that seems to be consuming a lot of the CPU. So it'll go find all the queries running on the instance, and then again order them by execution time and find the the slowest running query that's possibly causing this CPU utilization to be high. And maybe the text is a little small to read, but it's also smart enough to come back and tell me that I am running a load test on this. So it's actually coming back and telling me that all of the load is from one single query being run by one single user from one single IP, right? So it's also figured out that what I'm doing is a load test and it's not a real application load. So it can do all of this in your developer's IDE, in whatever console that they're using, or an agent that you have custom built, because that's essentially the power of MCP, right? So it's democratizing access to all of this and letting you plug that into any surface that you so desire. It could be your automation framework, it could be your custom agents, it could be IDEs for your developers, and empower them to get access to this information. I should also mention that you can configure all of these MCPs to be read-only so that you don't have to worry about your developers taking action that was unintended and that you don't want them to, so that they'll get access to the information, they get access to the database intelligence that these tools enable, and then they can, if it's something that's remediable on their end, like improving the schema or improving your query, they take care of that. If it's something that's more infrastructure oriented, they can at that point raise a ticket, for example, on the platform team with all of this context in there on what they've discovered and how you could go fix this. Right, so that was a demo of how you can do this with MCP tools and IDE, but we've not done. We have a whole lot of other data cloud fleet management capabilities, really exciting capabilities that we're going to talk about today. And to do that, I'll invite Nitya back on stage, please. Thank you.
Thanks, Niranjan. As you can see, so many demos. We've empowered you guys, empowered everyone with database observability agent, enabled your developers to use it where they want, the choice of their IDE or any of their chat or console. Now we're going to zoom out and talk a little bit about the data cloud fleet management. We have recently redesigned our database center to be a single source of truth, to be a true unified fleet management platform. What does that mean? Whether you're using BigQuery, managed databases on GCE, or Oracle at Google, any of those, you can see everything together in a single pane via Database Center. Not only that, we are now enabling you and empowering you to use something called Gemini-powered prompt-to-console experience. With this experience, we are letting you to create your own hyper-personalized views, dashboards, UI, with simple natural language to generate the UI. So this is our way to enable you to the next generation of agentic UI experiences where you can create your own personalized user interfaces. Similarly, we are also taking you through something called Gemini-powered remediation solution. This is our agentic testing agent. What it does is it simulates before you apply any of your changes to production to understand how it's going to perform so that you know before you enable it in production that it works for you and it helps you. As you can see, these are all our continuation of our agentic platform story that we are building. We're not done yet. There are more to go. And one of the key things we are enabling is fleet maintenance, intelligent fleet maintenance. And what is this? This is a way where we are going to leverage all the system usages that you have and simulate it through our agentic platform to tell you what is the best time, best window for you to apply your maintenance so that you have the least downtime and you're not impacted during your peak hours. This is also enabled via Database Center. Similarly, the next thing that we are showcasing for you via Database Center is slow queries across your data fleet. You don't have to now go one query at a time to figure out what is needed. We're going to give you a view in Database Center for all the slow queries across your fleet so that you're able to take a remediation action, leveraging the AI-assisted troubleshooting journeys that Niranjan just walked you through the details of it. We are also enabling fleet health and inventory reports to be delivered to your inbox. Many of your leaders or stakeholders may or may not have the time to come and access it via the console. So what we are doing is delivering it to their inbox so that they're always informed and up to date about what is happening with their fleet and inventory. And we have many more features like this that we are delivering as part of this release to make it a true intelligent database management agentic platform. With that, I want to invite Govind to come and share a little bit more about how they plan to use all of these features in global payments. Thanks, Govind.
Thanks, Nitya. Hi, everyone. Hi, all. Hope you're having a great conference and had a great next night. I'm from Global Payments. Global Payments is one of the leading payment provider where we serve large enterprises to small local businesses, and we serve close to 6 million merchants across 175 countries. The amount of transaction volume that we move money is around $3.7 trillion, which is equivalent to GDP of France. We are a partner of choice for major brands, big brands, as well as local businesses. Google is one of our core partner, where we actually help process payments for Google as well. And we actually always put merchants at first. We have different segments we serve based on where they fit in from a business standpoint, big enterprises to a small and medium business, such as a local mom and pop shops or grocery stores, as well as we integrate our softwares into a lot of software platforms and provide an embedded experience within the software, be it a CRM or ERP to make payments, as well as in schools, if they wanted to do embedded payments or paying your residential aspects of it. About me, I'm one of the principal architects in Global Payments. I'm also contributor to the global ecosystem, from World Digital Technology Academy. I'm a senior member in IEEE, as well as a major contributor to Cloud Security Alliance, helping shaping up the AI from a safety security standpoint too. And when it comes to database management, there are challenges, right? If you look at, there are 3 core areas that I'm actually going to touch on. One, about the database engines. As our company is truly global, we have got hundreds of projects where we use databases which is fit for purposes, be it RDBMS or Cloud SQL, AliDB, or Spanner, or things like Firestore, as well as BigQuery, Bigtable. We actually use a lot of these technologies, as well as certain caching technologies like memory store. It's very difficult to have each specific consoles to look at each of those performances. That's where Database Management Center comes into the rescue to help us monitor all these different database types in one single pane of glass. Other thing, if you look at our organization, we have got grown through mergers and acquisitions. As you know, when the mergers and acquisition comes, as the workloads will be actually like coming in from their different GCP arcs. How do we actually like monitor that? That's one of the challenge. Users has to actually like flip between different consoles, like by logging into different profiles to see them. That's where like we will be actually like talking about how like some of the innovation what Google has done as part of their agentic data platform comes to the rescue for a global platform like SRE team, platform support team to enable how they could actually like work across different multi-org environment to support at scale to keep systems always available. And other areas like if you look at this, the health categories, like we are highly regulated, so where we have to like secure our data. Data protection is a core principle that we never, it's a non-negotiable. As well as the security of the databases is very important because we deal with a lot of like sensitive information, transactions. So protecting those databases in a secure way is very important to meet like various like regulatory compliance requirements as well as protect the society. And other aspect is availability is a non-negotiable as well because resiliency is the key for our business because we never know when a transaction would actually like hit through our systems and when somebody like needs certain information. So always available is our goal, and that's where like database like management center helps us to look at various like deviations and how to actually like correct them. The other aspect, if you look at, there are like various ways to actually like enable that. Looking at like, okay, who need to know what the fleet that they are actually like looking at. You can actually like go to the granular level at a project level access to the org level access. That's the level like what the flexibility the database management center gives to us. So what we have actually like done is we have enabled the database management center in very selected like landing zones to give the DBAs a view of what the fleet like looks like at those landing zones. And in our enterprise, we allow landing zones to be managed autonomously by a group of like platform teams who supports a set of like applications or portfolios. So that's why it's very important for us to enable at a landing zone level. And for app developers in a non-prod environment, developers need to know, okay, what's actually like happening when they develop something, what are the impacts that it would actually like bring in, right? So that's where we actually like provide them granular level access for the non-production projects, as well as we give them limited like least privilege principles by applying custom IAM policies to the respective like projects, individual GCP projects, where their workloads run, which they need to have read-only access to gain the insights on the database fleet that what they are actually like supporting. And why agentic AI is actually like very important from a database SRE perspective is the scale problem. Like DBAs cannot actually like go and look at things, or even the platform teams or even app developers. They can't go and actually like look at stuffs at each and every like level, like because it's going to be reactive in nature. That's where the agents, where you actually like define the skills on the agents, what are the specific areas that you want to look at from continuous like feed polling perspective, where the agents will actually like query the database management center MCPs and pull insights and health signals around it, and then help like in terms of like assessing, okay, what needs to be done, and having a human in the loop approval when it comes to like executing a change where it has to be coordinated, and there should be like agents will work through our like CI/CD processes to make sure it actually like goes through proper like stage gate to get there, as well as the guided like remediation playbooks has to be like defined, where the step-by-step remediation, you define it as part of the skill. Hey, if you get this insight, as like Niranjan showed the plans, right? how does that agent need to interact with this plan and like provide insights for somebody to look at that plan and take a conscious data-driven decision. And other aspect, like if you look at on the agentic workflow, where the agents like would actually like poll from an ingestion perspective using the database management center, then it applies the classification principles, like you add a skill to the agent to have a classification principle to identify, hey, what kind of like issues are, and delegate it to sub-agents, so that way those sub-agents will have like specific skills to work on, and then like propose a remediation plan using an orchestrator pattern from a multi-agent ecosystem standpoint, and then have a human in the review and execute it based on your standard IT governance processes. That way, it actually like applies standard guardrails, etc. As well as if you look at from an architecture standpoint, the way how we are looking at to implement going forward is using MCP gateway via Apigee and connecting it to the multiple org, and Apigee can actually like orchestrate those multi-org access from a common like SRE agent, where without crossing like boundaries of orgs, you can still like gain access to it by applying like granular level access